Picture this. You wake up in Manhattan, savor a fresh bagel at sunrise, and by the time your coffee cools, you're already walking along the golden sands of Bondi Beach in Sydney, before most people have finished breakfast. The notion sounds like something ripped straight from a science fiction blockbuster, but SpaceX, led by the ever-ambitious Elon Musk, is wagering that its Starship rocket could soon turn this fantasy into reality. Could humanity be on the verge of a transportation revolution that will shrink the world? Or is this vision destined to remain as elusive as a mirage shimmering on the horizon? The idea of using rockets for earthbound travel, known as point-to-point rocket transport, is not new. The seeds were sown decades ago during the feverish optimism of the space age. Back in the final decades of the 20th century, aerospace giants like Lockheed Martin proposed radical concepts such as the Venture Star, a visionary, fully reusable single-stage-to-orbit vehicle. The Venture Star, if successful, would have enabled passengers to traverse the continental United States in mere minutes, connecting places like Los Angeles and New York faster than the time it takes to finish a movie. Futuristic promotional materials imagined travelers sipping coffee and reading newspapers while rockets whisked them across the country. However, the program ran aground on the harsh reefs of technological limits and spiraling costs. The experimental X-33, Venture Star's prototype, was canceled in the late 1990s after engineers failed to perfect its advanced composite fuel tanks. The dream was shelved, gathering dust as the world moved on to more incremental improvements in aviation. Fast forward to the 21st century, and the torch of audacious innovation has been picked up by a new generation of space entrepreneurs. The commercial space sector has exploded, with companies like SpaceX, Rocket Lab, and Blue Origin racing to rewrite the rules of what is possible. Amidst this modern-day space race, SpaceX's Starship stands as both an icon and a disruptor. Officially announced as a Starship goal over 6 years ago, point-to-point rocket travel quickly captured the public imagination. Musk's vision, to make intercontinental journeys measurable not in hours but in minutes. During the initial unveiling, the concept was presented as just one facet of Starship's larger mission to make life multiplanetary, serving not just Mars-bound pioneers, but Earth's busy travelers as well. SpaceX proposes that its Starship, a fully reusable stainless steel behemoth capable of carrying over 100 passengers, could slash the journey from London to New York to less than half an hour. Gwynne Shotwell, SpaceX's formidable president, once quipped in a TED interview that passengers would spend more time on a speedboat ride to the rocket's ocean platform than in the rocket itself. Imagine that. The most time-consuming part of your trip would be crossing the harbor, not crossing the Atlantic. According to the company's own materials, the flagship routes would see Starship launching from city-adjacent offshore platforms, arcing into the upper atmosphere at hypersonic speeds, and landing with pinpoint precision on another platform halfway across the globe. The momentum behind this idea is no longer confined to PowerPoint slides and speculative interviews. Government agencies are now placing significant bets. The United States Air Force Research Lab, together with the Space Force, has reportedly funneled between $200 million and $300 million into a program called Global Logistics, designed to explore the possibilities of rocket-based rapid cargo delivery. The rationale is compelling. In scenarios ranging from military emergencies to disaster relief, the ability to deliver tons of equipment or supplies to any point on the planet within an hour could be a game-changer. Other players, such as Rocket Lab with their Neutron rocket, are also being considered for these rapid delivery missions. Neutron, while smaller than Starship, is engineered as a reusable two-stage medium-lift rocket burning liquid oxygen and methane, showcasing the diversity of technological approaches being explored. Expert voices are lending credence to the military use case. Carter Palmer, an analyst at Forecast International, points out, the ability to deliver cargo anywhere on Earth offers a distinct advantage in both warfighting and humanitarian aid scenarios. Imagine a sudden earthquake devastating a remote region. Within less than 60 minutes, Starship could theoretically deliver life-saving food, water, and medical personnel. Conversely, troops, vehicles, or critical equipment could be deployed to crisis zones before adversaries have time to react. The strategic implications are staggering, with echoes of the Cold War's race for technological supremacy. Yet, for every visionary, there are legions of skeptics. The challenges are as immense as the rocket itself. Rockets, for all their glamour, have nowhere near the reliability or safety record of modern commercial airliners. Even SpaceX, which has achieved a remarkable string of successful Falcon 9 landings, still faces catastrophic failures on occasion. Neil S. Lockman, CEO of Titan Space, sounds a note of caution. Once Starship lifts off in a ballistic trajectory, there is no way to control or maneuver it until re-entry. In essence, passengers would be committed to a high-speed arc with little room for error, and the stakes, hundreds of lives, billions of dollars in cargo, could not be higher. Safety is not the only hurdle. Launching a rocket near a major city is a logistical and regulatory nightmare. Rockets are thunderously loud. A single launch can generate a sonic boom powerful enough to rattle windows and set off car alarms for kilometers around. For context, even SpaceX's Texas Starbase is located over 8 kilometers from the nearest population center, with strict safety exclusion zones. Bringing regular rocket launches closer to urban areas could raise serious public opposition, not to mention the labyrinthine maze of local, national, and international regulations that would need to be navigated. The Federal Aviation Administration and environmental agencies would scrutinize every aspect, from noise abatement to pollution controls. Environmental concerns loom large. While SpaceX touts the reusability of Starship as a sustainability breakthrough, rocket launches remain far more carbon-intensive than commercial flights for the same payload. The use of methane as a fuel, while cleaner than kerosene, still results in greenhouse gas emissions, especially when considering the frequency of flights required for mass adoption. Environmentalists warn that even a modest schedule of daily launches could leave a sizable carbon footprint, potentially undermining global efforts to combat climate change. There is also the question of upper atmosphere pollution, with some studies suggesting that rocket launches may have outsized effects on ozone depletion compared to traditional aviation. Then there is the issue of ticket prices and economic viability. Air travel has, over the past 70 years, become remarkably affordable. The relentless drive to reduce the cost per seat has democratized travel, opening the skies to nearly 4 billion passengers annually by the end of the second decade of the 21st century. For Starship to compete, it must not only match this accessibility, but overcome the additional costs of specialized infrastructure, the offshore platforms, transfer boats, and new safety systems. Some analysts speculate that, at least in its early years, point-to-point rocket travel may be reserved for the wealthy elite, high-priority cargo, or critical government missions. The dream of regular families rocketing across the globe remains distant, pending radical reductions in launch costs and infrastructure scaling. The logistical complexities extend beyond the rocket itself. The entire journey would likely involve a combination of transfers. First, from the city center to a port, then by high-speed ferry or catamaran to an offshore launch platform, which could be anywhere from tens to hundreds of kilometers from shore to comply with noise and safety regulations. Then the rocket flight itself. And finally, another water transfer at the destination. What is advertised as a 30-minute flight could, in practice, become a multi-hour odyssey. Even SpaceX's Gwynne Shotwell has candidly acknowledged that the longest part of the trip might not be the rocket ride, but the commute to and from the launch pad. Despite these daunting hurdles, the allure of point-to-point rocket travel remains potent. If SpaceX or another company can crack the code, the implications would be seismic. International business would be transformed, as executives could attend meetings on multiple continents in a single day. Global supply chains could be reimagined, with just-in-time deliveries no longer constrained by the tyranny of distance. Emergency response teams could reach disaster zones or epidemic outbreaks faster than ever before, potentially saving thousands of lives. Even personal relationships and family ties, strained by distance for generations, could be rekindled as travel times shrink. The potential ripple effects on urban planning and real estate are profound. Cities with spaceport access could experience economic booms, attracting new industries and high-skilled jobs ranging from rocket engineering and maintenance to hospitality and logistics. Conversely, some communities may resist the noise and risk, leading to contentious debates about where to locate these futuristic facilities. There is also the specter of geopolitical competition, nations racing to establish their own networks of launch sites, potentially reshaping global alliances and rivalries. But what about the wider historical context? If we look back, we find that every major transportation leap, from the steamship to the locomotive, from the propeller plane to the jetliner, has upended societies, economies, and even the fabric of daily life. When commercial jets like the Boeing 707 entered service in the late 1950s, they slashed transatlantic travel times from over 12 hours to less than 7. The result was an explosion in global tourism, international business, and cultural exchange. The world became smaller, more interconnected, and, for many, more accessible. The rise of budget airlines in the late 20th and early 21st centuries continued this trend, democratizing travel for billions of people. Rocket travel, if it follows suit, could be even more disruptive. Picture a future where New York is just as close to Tokyo as Chicago is today, or where Johannesburg and London are connected in the time it takes to watch a television episode. New industries would spring up: spaceport construction firms, virtual reality training companies preparing passengers for the G-forces of launch, luxury rocket cruise experiences, and more. Universities would rush to offer new programs in aerospace logistics, space law, and environmental mitigation. Yet progress will not be measured by technology alone. Regulation, public trust, and market forces will all play decisive roles. The aviation industry's safety culture, honed over decades of hard-earned lessons, sets a high bar for any would-be rocket airline. Even a single high-profile accident could set back public acceptance by years, if not decades. Insurance costs, liability frameworks, and international treaties governing space travel would all need to be rewritten. The Montreal Convention, which governs airline liability, would be only the starting point for an entirely new era of travel law. Military applications may indeed be the first domino to fall. The logic is straightforward. For urgent cargo or personnel delivery, cost is less important than speed. The United States military, recognizing this, is investing heavily in both Starship and Rocket Lab's Neutron for so-called rapid global logistics. If these experiments prove successful, the model could spread to other nations and, eventually, to the private sector. However, this opens a Pandora's box of ethical dilemmas. What happens when the world's fastest delivery system is used for conflict rather than relief? Could we see a new arms race in space, or the militarization of civilian infrastructure? On the commercial side, some futurists and industry analysts, such as Brian Wang of Next Big Future, argue that full-scale replacement of long-haul air cargo by rockets could occur within the next decade. This could be especially transformative for high-value, time-sensitive goods. Think organs for transplant, critical machine parts, or even perishable luxury foods. But for passenger travel, the hurdles are higher. Safety, comfort, and above all, cost must all reach levels comparable to or better than today's jetliners. The experience must also be accessible to people of all backgrounds, not just the ultra-wealthy or government agents. The noise issue, meanwhile, may be the most intractable. Rocket launches are not just loud, they are, by current standards, off-the-charts deafening. Even with advances in noise abatement and launch technology, it is likely that most platforms will need to be located far from major cities, adding time and complexity to the journey. This challenge is not unique to SpaceX. Other would-be rocket airlines, such as Blue Origin or the now-defunct Virgin Galactic suborbital ambitions, have also wrestled with the problem of bringing space travel closer to the masses without disrupting daily life. Environmental impact will be a hotly debated topic for years to come. While Starship's use of liquid methane is cleaner than traditional rocket fuels, it is not emissions-free. Each launch releases not only carbon dioxide but also water vapor and other byproducts into the upper atmosphere, where they can have outsized effects on climate and ozone. As the world grapples with the urgent need to decarbonize, pressure will mount for SpaceX and its competitors to develop greener propulsion technologies, perhaps harnessing synthetic fuels, hydrogen, or even advanced electric propulsion in the future. For the curious public, the best advice is to watch for concrete milestones rather than marketing hype. 6 years after its announcement, point-to-point Starship remains on the drawing board, with technical demonstrations, regulatory approvals, and infrastructure build-outs all ahead. But momentum is real. The United States military is investing. SpaceX is planning its first test landings for this project on Johnston Island in the Pacific by the year 2026, a tiny atoll with a storied past as a Cold War testing ground. Rocket Lab is hot on SpaceX's heels, and other international players are watching closely. The first true rocket commuters may well be emergency responders, medical teams, or cargo handlers, not vacationers or business travelers. So, can SpaceX really pull off the ultimate transportation revolution, making rocket-fast, affordable global travel an everyday reality? The answer is tantalizingly close, yet still out of reach. The pace of change will not be set by Elon Musk's ambition alone, but by a complex interplay of technology, regulation, economics, and public trust. If even some of these challenges are overcome, the consequences for humanity could be transformative, from the way we work and connect to the very structure of our cities and societies. Until then, the dream of breakfast in Paris and dinner in Sydney remains just that, a dream, but one grounded in serious engineering, billions of dollars in investment, and a relentless drive to make the impossible possible. And here's a fascinating secret. Although Elon Musk often captures headlines with talk of Mars and lunar bases, the first real Starship landings for Earthbound point-to-point travel are being targeted for Johnston Island in the Pacific by the year 2026. This remote islet, once host to secret missile tests and nuclear experiments, could soon become the launchpad for a new chapter in human mobility, a chapter as revolutionary as the age of steam or the dawn of flight. If this story has sparked your imagination, do not forget to like, subscribe, and ring the notification bell for more deep dives into the future of global economics and technology. What would you do if you could traverse continents in less than an hour? Would you reunite with distant family, chase business opportunities, or simply explore the world? Share